Cosmopoulos and Elias Cisneros. So great to have the extra support, and we're just really pleased to have another seminar series going on today. So this is the Conservation Impact, Evaluation, and Implementation Science Seminar Series, and we're back at it the first Tuesday of every month, 10 a.m. Eastern. Next slide, please. Great. So as a reminder, I mentioned this is an activity of the SCB's Impact Evaluation Working Group. And this working group has some great ambition to advance evidence-based biodiversity conservation across the globe by supporting the application of counterfactual approaches to understanding impacts. And I think many of us know the impacts that this group has had, and maybe some of you are new to the group. So welcome, and we're looking forward to having people from academia, from practitioner groups, all involved and supporting this really fantastic effort of the working group. So if you're new, please find out more on our website, follow us on X, or sign up for our email list. Next slide, please. So today we're really pleased to have Jonah Busch with us. This is a reschedule due to very happy events of Jonah growing his family. So he's back with us, and he'll be speaking on what drives and stops deforestation, reforestation, and forest degradation, an updated meta-analysis. I know many of us are really looking forward to this presentation and have been following his work. And then great news, in October, we have Daniela Miteva from the core faculty at the Sustainability Institute at Ohio State University. So Daniela is a great leader in this space, and we're really looking forward to hearing what she's been working on. But before we dive into Jonah's talk, just some usual housekeeping. Hopefully this is familiar to many of you, but let me just emphasize that, well, again, we'll have a speaker, Jonah Busch, followed by a moderated Q&A. And the way that question and answer session works is that you post your questions in the chat, and we also have the option for live transcript if you would like to take advantage of that. Hopefully folks are familiar with that on Zoom. Otherwise, look at the tab that says more and go to live transcript. And as always, this seminar is recorded, and you can find it later on at our Vimeo channel or our YouTube channel, and catch up on previous seminars as well. And if you're going to post on social media, we would love it if you use the hashtag Tuesdays with Team Counterfactual and tag IDoImpact. Okay, next slide. Okay, with that, let me hand it over to Jonah, who is going to present some results from an updated meta-analysis on what drives and stops deforestation, restoration, and forest degradation. Thanks, Jonah.
Thanks, Sheila. Are you able to see the presentation?
We are seeing it now. Thank you, Jonah.
Terrific, thanks. So this, as Sheila mentioned, is a presentation on what drives and stops deforestation, reforestation, and forest degradation. And I'll be explaining how Khalifi, Freddie Gallen, and I conducted our meta-analysis. I will be answering the question in the title, but it takes more, there's more than just a one-sentence soundbite answer to this question, so I can't give it up front. You'll have to wait through the presentation to see the full answer. And because this is Tuesdays with Team Counterfactual, I'm going to be trying to give a special focus on causality for this audience. So as you watch this presentation, I hope that you'll get a sense of just how massive an undertaking this project was, and consequently why it took us so long to do this. So Khalifi and I started this project in 2018, fresh on the heels of a previous meta-analysis on the same topic that had just been published. In 2018, I was at Earth Innovation Institute. Khalifi was at the University of British Columbia, and our funding came from NORAD. And when the paper was published 5 years later in 2013, I had moved to Conservation International. Khalifi was at the Ministry of Environment of the British Columbia, and our funding was from Anne and Tom Friedman Fellows Program. And now, a year after that, Khalifi is still at the Ministry of Environment. I'm on a career break. I'm taking care of a 7-month-old baby. And that is the reason why this talk is being given now rather than originally scheduled on February 6th. So Seb and Sheila and the whole team, Counterfactual, had set this meeting for February 6th. And at February 5th at 9 p.m. at night, my wife, her water broke, and so we rushed to the hospital. And basically the last thing I did was text the team and let them know I wouldn't be able to give the talk. And so on February 6th, instead of giving the presentation, my wife and I welcomed our daughter, Amelia, shown at that time on the left with a face no bigger than a Valentine's Day sugar cookie. And then now, 7 months later, she's grown into this amazing person who's fascinated by the world around her. And importantly for this presentation is thankfully able to sleep long enough to let her dad give talks and do things like that. But anyway, I know you're not here to see cute baby pictures from a proud parent. You are here for forests. And so without further ado, let's talk about forests. People are interested in forests for all sorts of reasons. And so maybe you are interested in forests because you're interested in climate change, and deforestation is the second biggest contributor to climate change after burning fossil fuels. Or maybe you care about biodiversity, and forests are home to more than 2/3 of all land-based plants and animals, including some very cute ones like this Coquerel's sifaka in Madagascar. Maybe what you really care about is agriculture and the interplay of agriculture and forests, how agricultural expansion is the leading cause of deforestation globally, especially for beef, soy, and palm oil. Or maybe you're just a person who cares about data, and forests for a while now have had really, really excellent data, especially compared to other environmental biomes. So, for example, this revolutionary data set by Hansen et al. That's now more than a decade old. Or maybe you just like forests for the same reason. Marge Simpson likes potatoes, which is you just think they're neat. And that's fine. So whatever the reason you like forests, you are not alone. Many, many researchers have taken an interest in forests and deforestation and what causes it and what stops it. So over the last 3 decades now, there have been hundreds of published studies on what drives deforestation and what stops it. And on this call, I think it's very likely that some of you are among the 1,000 or so authors who have published a primary research study in this field. And some examples are shown here. What's the effect of indigenous land rights on deforestation? What's the effect of law enforcement, of payments, of agricultural intensification on deforestation, and much more. And before I continue, this is probably a good time to give some definitions of the main terms that I'm using here in this title: spatially explicit econometric studies of drivers of deforestation. So deforestation, in this case, means the change in land cover from forest to non-forest. Drivers are just any factor that contribute to accelerating or slowing deforestation. That could be biophysical, economic, social, political, and so on. Spatially explicit means that the data was mapped. So generally overlaying maps of where deforestation happened with maps of where the driver variables were. And econometric in this case, meaning the results of a multiple regression analysis or quasi-experimental analyses such as matching, but not experimental analyses. So all of these, as I mentioned, hundreds of primary studies have led in turn to quite a few review studies over the years, where the authors have aggregated those primary studies to try to arrive at general conclusions. And while all of these are valuable, most of them did not systematically screen studies for inclusion or exclusion. Most of them did not arrive at their conclusions quantitatively, they're just qualitative. And most of them were not comprehensive in terms of which driver variables were included or which geographic regions were included. There's sort of scattered exceptions to each of those. As of our previous paper, there was only one paper which systematically evaluated all drivers and did so quantitatively, and that was our previous paper in 2017. This one published also in the Review of Environmental Economics and Policy. And in that paper, which was systematic, comprehensive, and quantitative, the results of that paper were, we found two factors which were consistently associated with more deforestation, that's roads and agriculture, and four factors that were consistently associated with less deforestation. And those were protected areas, payments for ecosystem services, law enforcement, and indigenous peoples. And sort of a spoiler alert, all that is still true. So why did we feel it was necessary to write a sequel to this paper? Why not just leave it where it was? And there's a variety of reasons. So we decided, fresh on the heels of the previous paper, to already start updating it. In large part because of this paper I showed earlier, Hansen et al. 2013, and because of this groundbreaking new data, you can see in the panel on the left that the number of studies of drivers of deforestation really just ballooned after this paper came out. So from the 18 years before 2013, there were 121 studies published that met our criteria. In the 6 years after, there were 199. So a lot more studies. And because there was new data, researchers could study anywhere in the world and not just the small handful of countries where there was good data beforehand. Researchers had also started publishing on many new topics. So just for example, commodity certification, agricultural yield, conflict, democracy, gender, quite a few others only began to be studied after 2013. And there's now data that lets us study reforestation and forest degradation as well. And although it's in the title of this talk and the title of the paper that the talk is based on, I'm not going to be spending much time on those today, but they are in the paper. And finally, having provided this resource for policymakers and researchers, we wanted to keep it up to date with the latest findings. So just as we did in the previous paper, we wanted to be very systematic about which primary studies we included or excluded. So we had a 6-step screen. We started by assembling a universe of hundreds of candidate studies. We used a variety of keyword searches, plus literature reviews in the papers that we found and Google Scholar citation lists from the papers that we found. And we had all these potential papers, we started screening them. So we only included papers that were published in peer-reviewed journals. We excluded book chapters or working papers or policy reports. And after doing that, we had 280 candidate studies. We only included studies where the dependent variable was a direct indicator of forest, be that forest cover loss, forest cover gain, forest degradation. But we excluded any where the dependent variable was some other type of indication, such as an index of fragmentation or habitat quality or agricultural expansion. Then we only included papers where that measure of forest was remotely sensed, meaning it came from satellite or aircraft and was mapped. We excluded studies where the indicator was based on field inventories or census data or household surveys or the FAO forest resources assessment, basically anywhere where the data was self-reported rather than collected systematically using technology. The article had to have at least one table that presented the results of a multivariate econometric analysis, including significance at the 95% confidence level, or statistics from which we could derive that 95% confidence level. And the econometric model of forest cover change had to include at least one anthropogenic variable. So there are studies that look at whether forest cover change is, how it is affected by only biophysical or chemical variables. We didn't include those. And finally, one new screen for this sequel paper to the previous one, we eliminated studies that had disqualifying methodological flaws. And in this case, there was one study that had such an egregious methodological flaw that it invalidated the results and we couldn't include the study. This was really rare. Generally, we gave the original researchers the benefit of the doubt that what they were doing had passed peer review and made sense. And if they chose to do things that way, that was, we included it. So we ended up with 199 studies post 2013. We added this to the 121 studies from the original paper to obtain 320 studies that we included in this meta-analysis. And many of them you open up these studies and they look like this. You know this because you've written studies like this yourself or have perused a lot of them. And this is where we got our data. So these maps on the left, you see maps of where deforestation took place over a historical time period. That's going to become the left-hand side variable in a regression in these original primary papers. And then all of the right-hand side variables of that paper, so in this case, protected area, protected forest, forest patrimony area, and so forth. Those are the rows here of this table shown on the right. And the columns on the right are each one regression analysis. And each of the cells, which is the intersection of a regression analysis and a variable, has a coefficient. And we're going to code that coefficient, and that is going to become the data that goes into our paper. So we're going to code the coefficient in one of three ways. We're going to drop it in one of three bins. We're either going to code it as having a positive and significant correlation with deforestation, or a negative and significant correlation with deforestation, or no significant correlation with deforestation in a multiple regression. We're not going to, there's more information there than we use. So there's information on what's the effect size. There's information on what's the p-value. we're not using that information beyond, as I said, whether it's positive insignificant, negative insignificant, or not significant. Sometimes we're going to have to invert the dependent variable. So as I said, we're talking about correlation with deforestation. But if what they're showing is correlation with avoided deforestation or with forest cover, we need to flip that to get the relationship we want. So turn a negative into a positive and a positive and a negative. And likewise, sometimes we need to invert what's happening with the independent variable. So looking here, they have one variable that's called distance to mines, distance to the nearest mine. But you can imagine another paper that instead shows percent coverage of mines within a local radius. So instead of having, mines being less and less of a value, as the number goes up, it's more and more of a value. So again, we would flip that. We'd invert it. Having gathered all those variables, we group them together into categories. So I'm showing you here, this category is soil suitability. It's one of about 40 or so that we end up including in this paper. And you can see all the different the different variable names from the original papers that get lumped together in our meta-analysis under soil suitability. And there's lots and lots of them. And this was somewhat subjective lumping on our part. And then once we have, as I mentioned, for each individual coefficient, we have a positive insignificant, negative insignificant, or not significant. We add those up for the entire category. So for soil suitability, we add up all the times the soil suitability variable was positive insignificant, negative insignificant, or not significant. And I should have mentioned earlier, we have 15,000 of these coefficients that we coded and included. And that was done primarily by Khalifi. So shout out to Khalifi. And then I checked all of those afterwards. So we had double coding there. After we add up, so for soil suitability, we have a number that are positive and significant, number that are negative and significant, number that are not significant. To get our statistic for soil suitability as a whole, we take the ratio between the number of positive and significant and the number of negative and significant. And if the ratio of those two is different than what you would get from flipping a coin repeatedly, we say the variable is consistently associated with higher deforestation or consistently associated with lower deforestation. And if that ratio is not different than what you'd expect from flipping a coin repeatedly, we say there's not a consistent association. There were some other aggregation metrics, alternative metrics that we did use and include in the paper, but that's the main one. One important feature of this study that I'd like to mention, we included all of these coefficients, whether or not they were the focus of the original study. So for the category community forestry, we would include evidence from a study that was hypothetically called, "Does community management protect forests in Nepal?" Something focused on community forestry. But we'd also include evidence from studies called "What drives deforestation in Nepal?" So something that's general and agnostic to any particular driver. Or we'd include something hypothetically called "What is the effect of remittances on deforestation in Nepal?" that just happened to include variables on community forestry. So this is different than what you would get, different than the evidence you would include if you were to run a meta-analysis, a qualitative review on community forestry and deforestation, where you'd probably just be looking at papers that included community forestry. So I'll come back to this, but this is another feature of our paper, of why it's good to comprehensively include drivers when you're looking at even at individual drivers. Okay, and these are our results. And for most of the rest of the talk, I'm going to be showing this figure. So I'll talk through what you're seeing here. So the x-axis of this scatter plot shows the number of times in our database for each category we had either positive and significant correlation with deforestation or negative and significant results. So for the greater soil suitability, the category I showed before, it's around 120, 130 times that showed up as either positive and significant or negative and significant. The times it was not significant is not included in this number here, although it's certainly in our database. The y-axis here shows the ratio between the positive and significant and negative and significant results. So the higher up the dot is on this plot, it means a greater association with more deforestation, and the lower down it is, it means a greater association with less deforestation. And then the third thing to look at here are these dotted lines, these curved dotted lines. Those are the threshold, the 95% threshold of significance, meaning that if it's above or below those dotted lines, it's different than what you'd expect from a repeated coin flip. If it's between the two dotted lines, you could have gotten that result just by flipping a coin many times. So in the case of greater soil suitability, it is it's associated with greater deforestation because it's in the top half of the chart rather than the lower half of the chart, and it's significant because it's above that upper dotted line. So now that you know what you were looking at here, you can see the dots are each of those different categories. I can tell you what are the main findings. So I'll just run through what we see as the biggest general findings of the paper. And then, as I mentioned, I'm going to try to talk about causality more specifically, because what I'm talking about here is an association between these findings and more deforestation. But as everyone on this call knows well, an association doesn't necessarily mean a causation. And so we'll get into that. So what are some of the main findings here? We find that there are several categories that are consistently associated with higher deforestation. A lot of them fall into under accessibility. So places that are flatter or lower elevation have more deforestation. Places that are easier to access because they're nearer to roads and urban areas have higher deforestation. Also correlated consistently with more deforestation is economic returns, higher economic returns from agriculture, from timber, from livestock. Generally, the more of that is going on, the more deforestation there is. You can see there's a few exceptions here, like agricultural yield or timber price. We talk about in the paper why some of those are exceptions. Demographics is a mixed bag. So more wealth is associated with more deforestation. More indigenous peoples associated with less deforestation, but not a lot of relationship for more women or greater education. There's also, when it comes to what stops deforestation, there's some policies that are consistently associated with lower deforestation. And in this slide, I've lumped together public policies with private actions as well. But protected areas, commodities certification, law enforcement, payments for ecosystem services, and some other things. But this is in stark contrast to other types of policies that I term as indirect. They're not meant to affect deforestation, and in fact, we find that they don't. Even though there are people who claim that they do, or in a wishful thinking world would like it if they did. So things like greater democracy, less conflict, more secure land tenure do not show up as consistently associated with higher or lower deforestation. Okay, so these are the general. Let's talk then about let's get into causality. And the way I'd like to do this is just by going through some examples. So with biophysical factors, it's generally pretty easy to say that the existence of a correlation or an association also implies a causal relationship. And that's because there's no reverse causality to be concerned with. So elevation affects deforestation because lower elevation has easier access and it's easier to clear trees. But there's no world in which deforestation affects elevation. I mean, maybe at you could think of some extreme thing where there's more landslides and the elevation changes slightly, but that's 1 in a million or something. Similarly, steeper slope, there's no reverse causality. There is, let's see, hotter is kind of an interesting one, because we know that deforestation raises temperature globally, and also a lot of recent research showing it raises temperature locally. But and we're actually we were the first study, the first review study that mentions heat as a factor for being for greater deforestation. So that's another kind of value of running this meta-analysis comprehensively, is we can find things that drive deforestation that haven't really been talked or identified before. So we have more on that in the paper, and I do think that's worth more study, especially given climate change. Okay, so that one's clear, but in other cases, there's a we've got this vicious cycle or this endogeneity to be concerned about, and it's much more difficult to claim causality. So for population, for example, there's both what would you say, a hypothesis that higher population causes deforestation, and also a hypothesis that higher deforestation increases population. So if you have more people, you have more demand for products, you have more labor supply in an area to clear forests, you get more deforestation. Is that happening? Well, we think probably it is. But also, if there's more cleared land, that's more space for people to move into, probably that's happening as well. So in order to claim that population is increasing deforestation, in order to claim it from a causal, econometrically sound point of view, we would need to have some kind of exogenous shifter where we're measuring the effects of a population increase that's quick and dramatic and unexpected, and importantly has nothing to do with how much unforested land is there, how unforested land is changing. And there really aren't very many studies like this. So it's tough to say that it's deforestation that population is causing deforestation, even though there's every reason to think that that's the case. but none of the studies in our review, definitively show that it's the case. So then there's in between those two extremes of the biophysical, where you can certainly say it, and population where you certainly can't. We get some other ones that are interesting, where there are some, limited but not conclusive types of conclusions you can draw. So here again, there's a vicious cycle between wealth and deforestation. So greater wealth makes it easier to buy machines or hire labor or access credit in order to clear forests. So more wealth leads to more deforestation. But on the other hand, deforestation increases wealth, because when you clear trees, you could sell timber, you can grow crops and sell those. And so again, there's a vicious cycle. And again, what we'd want is to look at cases where wealth has gone up for reasons that are independent of changes in forests. And there are, I'll show that, but one thing I want to say before showing those results. This is a surprise to a lot of people. Just about every time I've given this talk to a live audience, someone asks, wait a minute, you're saying wealth is correlated with deforestation? I thought poverty is what's causing deforestation. That's a very persistent, I'd almost go so far as to call it a myth. The only reason I wouldn't call it a myth is because there are, in fact, a lot of places where people who are very poor are clearing forests. However, they're not clearing as much forests as people who are richer in the same area, or as much forest as they would clear if they themselves were richer. And that just shows up again and again in these studies as one of the most common findings. So that's, I think, always a surprise to people. In any case, we don't have to just look at correlation. We can look at exogenous shifters, and one of them is rural income support. So these are places where rural people are getting more or less influx of funding, either from public programs or from, let's say, remittances, and where more money is coming in for no reason to do with forests, there's more deforestation happening. So this shows us, from a causal point of view, wealth increasing deforestation. Let's see. I won't dwell on protected areas because this has been so covered by so many studies. You can see that it's the second largest amount of evidence in our meta-analysis after roads. It's very commonly included, very, very commonly the focus of studies as well. But let's see. Yeah, I think you are. I'm spending more time deciding what to talk about or not, but so we'll just say for a long time now, there have been quasi-experimental analyses that use matching to show the causal effect of protected areas on deforestation. And there's so many of these that we're able to separate out the causal from the non-causal inclusion of protected areas in a study. And in both cases, there's a significant association with lower deforestation. In the case of payments for ecosystem services, there have almost entirely only been studies that are quasi-experimental. And in these cases, again, we can say it's a causal relationship. Caveats and limitations. They're in the paper. I won't talk about all of them, but there's a couple I think are worth mentioning. One is publication bias. So with any meta-analysis, you're concerned that certain types of findings are more likely to be published than others. Could be a positive versus a negative finding, or in our case, maybe we're concerned that significant findings are more likely to be published. The way we tackle this is we compare whether the category was the focus of study or not. And we think that it's possible that if the study is about community forestry, for example, it could be more likely to have a publication bias in one direction or another. Whereas if that variable just happens to be included in another study on another topic, it seems much less likely that authors or editors or reviewers would have had some kind of publication bias around it. And in all but two cases, there were only two cases where we did find any difference, whether the focus was study or not. One was community forestry, one was poverty, interestingly. The other thing is heterogeneous effects. I want to be clear. When I say that just because we find that one category is consistently associated with higher or lower deforestation, that doesn't mean there aren't exceptions to this. In fact, there's almost always exceptions. When even though we say something generally holds true, we find the opposite, or one of the primary studies has found the opposite in some place or another. And so we tried to break down by regions or by income groups to see if there's differences across categories. And generally there were not, although in some cases there were. We also looked at time trends in the literature. I'm moving quickly here to leave time for questions. We looked at and trends, not just in what the methods and findings, but also the demographics. And so I'll mention that from the earlier study period to the later, for example, the number of first authors that were female increased modestly from 32 to 36%. The number of first authors who were from a medium or low income country increased pretty dramatically from 24% to 33%. The key findings I already went over, but I want to, what's the purpose? I want to show there's two purposes to presenting these findings. So one is for an audience of policymakers who are trying to figure out how to really make deforestation go down within their region. For example, the way Brazil did in the Amazon between 2004 to 2012. And if you look at the policies that that Brazil used and the policies that our paper says are found to be effective, there's a very high degree of overlap there. The second value to a study like this is for researchers like most of you to know what's already been done and therefore where we should be going. So, this is my list of my perspective on topics that I think are interesting and understudied and that I'd like to see more of done by the time we come back and try to do a third meta-analysis. So looking at commodities beyond agriculture, looking at the effects of alternative development paths, looking at the international connections to deforestation. I think that impact evaluations of specific actual policy initiatives in countries are always welcome and useful. And more with reforestation and forest degradation, which again, I didn't talk about much, but is in the paper. Khalifi and I both, we'd like to do a third meta-analysis. As I think you get a sense of now, this is a really, really big undertaking. It takes, every step of this takes a long time. I actually read all 300 plus of these papers, the same way you'd read any academic paper you're using. We'd like to experiment with machine learning to try to screen the papers and code the variables. So if anybody has done that or knows how to do that, please be in touch. There's, be room to welcome someone into a paper who really knows that stuff. We're looking for a sponsor. It takes multiple researchers, multiple years to make this data, to make this type of paper. So, if anybody knows of an institution that wants to fund this type of research, please be in touch. And then also to put in a plug for myself, when my daughter starts daycare in the near future, I'm going to be going back on the job market. So if anybody knows of open positions at institutions where you think I could add value, please reach out to me as well. And ideally, we'd like to be updating this every 5 years or so because there's so much new research coming out on this topic. So it's already time to be starting to think about doing this again. And if anybody, again, is interested in that in some way, please be in touch. And finally, just thank you to everybody who has published or is publishing primary studies in this field. As I mentioned, it's 1,000 authors or so whose primary work contributed to this paper. So keep up the great research and advancing the science. So thanks to Team Counterfactual and others. The ungated version of the paper and all of the data that went into it can be found at this link here, jonahbusch.com/academic. Scroll down to this paper and all of the relevant links are there. And your feedback and questions are welcome. So thanks, and back to the moderators.
Great, fantastic. Thank you so much, Jonah. Really wonderful presentation. I've got some questions already, but let me turn it over to Elias, who'll be moderating the question and answer session.
Yes, thank you very much, Jonah, for this great presentation. I have many questions in the chat already to collect. So I would like to not order them by chronologically, but maybe by data, method and results. So I think a few ones are already answered. Data can be downloaded on your web page, and yes, and the paper itself is online also available from your webpage. So let's dive into. So Oscar Andres Martinez asked, do you consider another reviews related to this topic of your type of topic, or have you excluded that? So I guess let me answer that also, right? You included all other review studies into your metadata analysis, or how was it?
Not well, yes and no. So it looks like I don't know if I can I share my screen again, or do we need? Because let me I'm going to go ahead and share my screen. So what we did not include data from other reviews, directly in, because we should be, although we mined them for their primary studies. But here's what we did. So we did a meta analysis where we compared our findings to every other published review. So if you've done a review study, then you are one of the names at the top, and we've tried to code what your overall findings were. And then we compared that to ours. So in this table that's also in the paper, you can look across and, for example, greater population, that's red all the way across. There's always this association between higher population and more deforestation. We find it, and other reviews find it as well. So that's how we compared our review to other reviews.
Okay. So another question was, do you have a good comment on which regions most of the papers that you reviewed or included here are from?
Yes. So there is a, let's see, actually, where's the, oh, this one shows it by middle income country. Yeah, so we have the precise percent breakdown in the paper, but you kind of get, you can kind of see here, looking Africa, Asia, Latin America, that more from Latin America, second most Asia, third most Africa, and then beyond that, Europe, North, some from every other region you could think of. But yeah, the paper has the precise breakdowns.
So I would turn a little bit to the estimation or the methods, right? So Renzo Gies asks, did you find many studies addressing the issues of spatial autocorrelation errors? And if not, how much do you think this could bias your results?
So we have again in the paper the precise breakdown of the number of papers that used a variety of approaches to identifying or what's the word, fixing, I suppose, spatial autocorrelation, and it's the minority, and it actually even went down from the first study period to the second study period, and yeah, most of them don't. I guess one way we try to address it in the meta analysis here is the bottom, sorry, the far right column shows the journal that the paper was published in, including, was it published in an economics journal? Was it published in a geography journal? And you could think that papers that are published in a geography journal are going to have reviewers and editors and authors who are more concerned about treating spatial autocorrelation. And so you could see, is there some kind of systematic difference across findings between papers published in a geography journal versus others? And yeah, so that's kind of the way we try to approach that at the meta-analysis level. We obviously can't go back and fix or change what's happening in the original studies.
There are many different questions on the results, and possibly you can just comment on it, right? Many are concerned about the scale of each study, right? Like small versus large area studies, or have you broken down results by geography, right? Because drivers can be very different from different regions, and also like by scales of the unit of analysis, right? Households, pixels, administrative boundaries, ecoregions. Do you have addressed these like heterogeneous effects?
Right. So here the second from the right column breaks down the findings by local versus regional versus national. And do we see difference across scales? You may be wondering, what are the white? That's where there's fewer than 40 coefficients that fall in that subcategory. So then we only include a value here if there's at least 40. That's kind of our arbitrary threshold for inclusion. So you can look in this table of, are there differences when you're across scale? Regions of the world, I mentioned, that's here. Upper, lower, middle income categories, that's here presented. And then there are others where we coded it and included it in our database, but did not present results. So the question about pixels versus households versus whatever other ones you'd use, administrative regions, we have that data. We did not put it in a figure in the presentation, but the data is there. So anybody, we welcome and invite everyone to go and look at this data for themselves. We made it accessible to the public to try and make it easier for other researchers to ask questions with the data that we didn't ask, or to ask new questions.
So with the data, for example, Aaron Zils is also asking if there are like broad categories. Have you looked at interactions, or can we look with the database into interactions, like say protected areas and conflicts, right? And these more heterogeneous effects of each of these factors, right?
Right, good question. I should have mentioned this earlier. So if we show our data, many of the studies are going to have these interactions terms, like what's one here, protected areas and indigenous, lands where those overlap. We excluded those from our analysis. They're in our database, so we coded all of these, but we have a very, very large portion of the database that's just interaction terms, and we didn't analyze those. There's also a very large section of the database that are names of variables that did not fall into one of these categories. So they're just kind of they slipped between the cracks or so. There's not a logical place for them. Although sometimes the ones that didn't meet a category in the first meta-analysis, in our second analysis, enough of them had that they could become their own category. So, and there's actually quite a lot of those. So, those are, gender or agricultural yield or temperature. Some of those, there were fewer than 40 to look at, and now there's more than 40. So we've included and drawn conclusions about them. So once again, the more primary studies get done, and if we're ever able to, fund and resource and do a new meta-analysis, those that fall between the cracks will start to, be analyzable in their own right.
So unfortunately, I think we are out of time. There are many, like 10 more questions. Please, maybe we can share them also with you. A lot on measurement, a lot on heterogeneity results again, right? So thank you very much for all the great questions.
Yeah, I'd love to continue answering questions. So maybe the organizers can let me know what's the most efficient way to do that, and I can respond to them by email or in the chat. Just let me know how, and I will do it. And then also, please, people, feel free to reach out to me. My email is there. JonahMBusch@gmail.com.
Okay, wonderful. Thank you so much, Jonah. It was a really engaging presentation. Interesting and important results. We will be sure to share the questions with you, and we'll figure out a way to streamline getting the information back out to folks. We look forward to seeing you all next month, October 1st. We will have Daniela Miteva with us from Ohio State University. Wonderful. Have a great day, everyone.